Let's imagine a ship sailing through the sea. It starts its journey from a point. Let's call this point the origin. First, the ship travels 150 meters in one direction. Then it changes its direction slightly and moves 120 meters. Finally, it changes direction once more and travels another 100 meters. So, the total distance covered by the ship is 150 plus 120 plus 100 equals 370 meters. Now, here's a question. If the ship has traveled 370 meters, can we tell where the ship is right now? Not really, because distance only tells us how much path the ship has covered, not where it is from the starting point. From distance, we can calculate speed, which tells us how fast an object moves, but not in which direction. The formula for speed is speed equals distance divided by time. For example, if the ship covers 370 meters in 185 seconds, its speed equals 370 divided by 185, 2 meters per second. That means the ship moves 2 meters every second, but we still don't know its final position. To find that, we need displacement, the shortest straight-line distance from the starting point, the origin, to the ship's final position, along with the direction. Displacement tells us the ship's actual position from where it began. Now, when we consider both displacement and time, we get a new quantity called velocity. The formula for velocity is velocity equals displacement divided by time. Velocity tells us how fast and in which direction the position of an object changes. So if we know the velocity of the ship and the time it's been moving, we can find out where the ship will be after that time. That's why velocity is more meaningful than speed. It not only tells us how fast something moves, but also helps us determine its position and direction. In real life, we can find either velocity or displacement using measuring instruments. Once we know one of them and the time, we can calculate the other. That's how scientists, pilots, and sailors track motion, using the relationship between velocity, displacement, and time.